Welcome to today's video. Today we are going to discuss about exponents. What is meant by an exponent? So as the definition says, an exponent tells you how many times to multiply a number by itself. So how many times? Here we are now writing a number 2 times 2. How many times? 2 times 2. So 2 2s are there. So we write a simple form is 2 to the power 2. What if we write 2 times 2 times 2? It's 8. The value is 8. So instead of writing this long numbers, we simply write 2 to the power 3. So 2 to the power 3 means 2 is multiplied 3 times. 2 is multiplied by itself 3 times. So 2 times 2 times. So 3 2's multiplied it. So that's how we understand from this. Basically, an exponent has a base value. So assume this is a number, a variable. So we raise a power n here. So this a is called the base of an exponent, and the n is called as an exponent. N raised the a raised to power of n. So we call this is the basic structure of n. We can write any number. We can write for a raised to 100. What does it means? That means a is multiplied by itself 100 times. So instead of writing the whole this line, we can just simply write a to the power. Okay, so this is the basic definition of an exponent function. Let's move to the some laws about the exponent. So we are going to see some one by one how we will manage the exponents. So what first rule is, we'll see product rule, product of power rule. What it basically says, when multiply with the same base, add the exponent components. That means if you have a same base of a to the power n, okay, multiplied by a to the power m. So in this case base are same but exponents are different. Okay, so how we can write this? So in this case we can simply make the expression into the simple terms. So a, we can write the same base, just add the exponent terms n plus m. That's it. So this is we call as product of power rule. So this one is important. So whenever we have an exponent in this form, we can simply add their exponents and make a value. So okay, let's go for an example here. So here I am writing 2 to the power 2 dot 2 to the power 2. As per the product rule, what's the value of this? So as per product rule, the same base you can write, just simply add the 2 exponent is, then the final answer is 2 to the power. Okay, we can check this answer. What's the value of 2 to the power 4? It is equal to 2 times 2 times 2 times 2 is equal to 2 times 4 from 8, 16. Okay, so just do this separately. So what's the power of what's the value of 2 to the power 2? It's same, 4 times 4 is equal to 16. So both are same. So we can say that when applying the product rule gives the correct answer. So this is how the product rule looks like. So let's go into the quotient rule. Quotient rule says when dividing with the same base, subtract the exponents. Okay, so what it says, let's write a to the power m divided by a to the power n. These are the two exponent we made. As per the quotient rule, we can say that we can just combine and we can just subtract the exponents. So m minus n. It's very important to consider two things. In this case, a should not be 0. A should be not equal to 0. If a is 0, then the entire expressions will be no solution, no solution. So make sure a is not 0. Second thing, follow the same order. See, follow the same order of this subtraction. It should not be, this is not equal to a to the power n minus m. No, this is wrong. It should be numerator exponent should be numerator exponent minus denominator exponent. This is the correct way. Okay, so this is the correct way of taking the quotient. Let's go for an example here. So 2 to the power 6, okay, divided by 2 to the power 2. That's the value. 2 to the power 6 minus, so base is 2, so 6 minus 2, the value is 2 to the power 4. This is the answer. So no need to find the value of these and find the value of these, then again subtract, then again divide, then make the value. This is it's very easy. Whenever you saw with the same base, if a quotient rules up, we can apply quotient rule when we see a fraction like this with the same base with an exponent. So we can directly write the answer like this. Okay, this is how quotient rule applies to an exponent. Okay, so moving forward to the third one is the power of a power rule. What is the power of a power rule? So when raising a power to another power, so when raising a power to another power, multiply the just exponents. So let's go and see this. This is then base a has a direct power m and the whole power n. This is how the definition says. When raising a power to another power, so a power m, the whole power n. We can just simplify and write like this. So base a, what you say, multiply the exponent, m into n, m times n. So this is the this is how we write power of a power rule. See, very important thing is you need to memorize this one. If we raise a power for an exponent, you can just multiply the two powers and write like this. Okay, let me go for example here. 5 to the okay, 4 all powers 3. What's it? It's just simply we can write 4 times 3 equal to 5 to the power 12. It's very easy. Okay. If you want to check, we can check like that. First we find the value of 5 power 4, then again that value again raise the power 3. We can get the same value to this one. Okay, moving forward, just we go for the power of a product rule. This is something we need to give more attention. See, distribute the exponent to each factor inside the parenthesis. So what's the power of a product rule? Just take a product rule first. A to the power m dot a to the power n. This is it. This is very easy. So what, distribute the exponent to each other factor. Now let it make it more easy to understand. So there will be a, okay, 2 to a dot b, so all power n. You can just write it as a to the power n dot b to the power n. What we do here, just distribute the common power to each terms and take the product. So whenever you saw a two variables inside the parenthesis have the common power here, exponent n here, then you can distribute, open the bracket, and we can distribute to each one. Okay, but make sure it is not equal. See, a plus b all power n is not equal to a to the power n plus b to the power. This is not equal. This only apply for products of two variables. It cannot apply to the addition or subtraction. This is exactly different one. There is no connection between subtraction and addition with this power rules. Okay, so it's not equal. This is not equal. So keep in mind, this is the main thing. You will be confused. Okay, you cannot do this. This is wrong. Only you can do with the products. Only you can apply this rule for the multiplication of two variables. Okay, this is entirely wrong. Keep in mind. Just go for the power of a quotient rule. So this is how we do is distribute the exponent to the both numerator and denominator. So we will write for this one. So a to the power a divided by b to all power n. The same thing we can apply here. A to the power n divided by b to the power n. This also is how we can distribute common power n to the numerator and denominator. This is very, very important when we go for the solving a problem. This will help you to find a correct answer. Next, zero exponent rule. Any non-zero number raised to power 0 is 1. So what the meaning is, a to the power 0. No need to think, no need to check anything. You can simply write the value is 1. Okay, any non-zero number a should not be not equal to 0. So make sure non-zero number, if an a is 0 to the power 0, in no solution, nothing. We cannot this infinity, we cannot do anything. There is no solution for this. So don't think about that. Just think, if a number, for example 2 to the power 0, it's 1. 3 to the power 0, it's 1. Any number raise a power 0, the value is 1. We can simply write 1. This is it. Okay, keep in mind this one, crucial thing. Let's go for negative exponent. Negative exponent. A negative exponent means the reciprocal. See, reciprocal. You can see that. If we can say that x power minus 2, what does it mean by x power minus 2? We can write as 1 power x square. We can remove the negative power. See, whenever you are facing a negative exponent, make sure you convert that into the non-negative terms, because when we have a negative terms in our equations or expression, it's more complicated for us to find a solution. So always keep in mind, when we have a negative exponent, try to remove that, eliminate that, and keep your answer or keep your expression very clean out of negative exponents. So any exponent have, for example, see 9 raised to minus 2, just write 1 by 9 square. That's it. So again, another example, 2 raised to minus 2 is equal to 1 by 2 square is equal to 1 by 4. This is how we deal with negative exponents. Okay, whenever you have a negative exponents, a to the power minus n, we can directly write 1 by a raised to n. This is how negative exponents, we deal with negative exponents. Okay, fractional exponents. Fractional exponents. What is meant by fractional exponent? See, every time you should not have a perfect exponent here. Sometimes you will encounter with like this 1 raised to 1 by n. So if we have a fractional exponent, we can, what is mean by is, we can directly write this as a square root function. It's a radical function. So we coming forward next video, we're going to deal with the radical expression. So we will have a detailed explanation for this. So for now, what we need to keep in mind that when we have a fractional component like fractional, we can convert this into nth root of the base. Okay, this is how we write the fractional exponents into radical form of square root. Okay, we are going to do some examples here. Here what you're going to see is 3x squared is x raised to minus 2 by x raised to 4. So keep in mind, first what we need to do is we need to eliminate this negative power here. So let's keep the 3 out of the fraction. So just we make the 3 out and keep the x raised to minus 2 by x raised to 4 here. So we can do it in two different ways. Show you. We can apply first a quotient rule here. So what quotient rule said, we can just minus, so 3 remains same, so the same base, if we have the same base, so we need to subtract, yes, write the same base here. So minus 2 minus 4, this is how we deal. So what's the answer here? Minus 2 minus 4 is, so 3x to the power minus 6. So again we can see a negative exponent came into our expression. So convert this into, remove the negative exponent. So 3 1 by x raised to 6. This is how it look like. Okay, then we go for same, we can write like this also, both are same, okay, we can either you can write like this, or you can, so the same thing we can do it in a very simple form. See, we can do another form. You can just interchange this. When we have a negative exponent, we can just directly write this into the denominator. So what we're going to do is 3 1 by x power 2 x power 4. So here what we're going to apply, this is a product rule here. So the answer is 3 1 by x raised to 2 plus 4. So is equal to 3 by x raised to 6. So the both way we can find the solution of this, find the simplified version of this expression. Okay, this depends upon you how you will use the radical, how we will use the exponent rules to simplify this expression. Next is, yeah, this is the next question. So simplify this one. So it's also very easy for that. So same way we do the last problem. We'll just remove the 4 out. Then here y raised to 3 divided by y raised to minus 5. So what my favorite way is, I just make the negative exponent in the denominator to the numerator. Y cube y raised to 5. So we can write this, we can apply the product rule here. So 4 y raised to 3 plus 5 is equal to 4 y raised to, let's say, 8. Very easy. So this is the how we simplify this. We can also use the what we can also use this quotient rule here and make the simplify the thing. So same answer you will get here. depends upon you how to use how what type of rule you are using to simplify. So next thing is it more, there's one condition here. Let's read the condition. Okay, so 3, simplify and find a solution without negative exponent. So you should eliminate the negative exponents here. So what we are going to do is, first we need to arrange the numerator and denominator here. So what we're going to do is first y cube or s raised to, so make the this one to the, so y cube is raised to 5, make the is raised to 2 here, 7 y raised to 7. So if I doing this one, what we're going to do is, so here we are apply the product rule here, and we apply the quotient rule here. Got it? Okay, so first we need to apply the both the same. So see, what is this? Is y to the power 3 minus 7. This is we apply the quotient rule here. The next is z to the power 5 plus 2 here. So the 7 remains here down. 7 remains here down. Is we go to the next stage. So why it's a minus 7, 3 minus 7. That's again we got the negative exponent here. Minus 4 and z 7 divided by 7. So we have a negative exponent here, so we need to eliminate this. So what we do is, yes, the same thing, keep the negative exponent to the denominator. So z raised to 7 divided by y to the power 4. Yeah, there is 7 here. So 7. So this is the simplified form without negative exponent. Okay, this is it. So this is how we can shift directly to the numerator to the denominator, or denominator to the numerator, according to the, when we find a negative exponent in somewhere. So if we find negative exponent in the numerator, directly you can put into the reciprocal, or put into the positive exponent in the denominator. So if you find a negative exponent in the denominator, directly you can put in the numerator. No need to go for any product rule or any wait for any quotient rule to apply for this. Just keep in mind, that's it. So it will be easy for your simplification. Okay, so what's the next thing? Simplify and find a solution without negative exponent, saying the same condition. So this is a little more complicated. So first we will simplify the terms inside the bracket. Okay, so what is it? So just move one by one. So 25 here. So 25, see, when we have a number like 25, it's a perfect square. See, it's a perfect square. Try to write like this: 5 square. Right, 5 square is 25. So like then it will gives you, when we have a bracket here, it will help you to pull out this perfect square out. So go for this x raised to 4. So where's another x term here? Yeah, yes, here is it. So x to the power 4 here. So there is a minus 6 here. So when you put this one in the top, in the denominator, we can write this as x raised to 4 to x raised to 6. Okay, then the next thing is y. Okay, same thing here. The y will go to the denominator side, because y cube is already here. Then this negative exponent of y will go to the denominator side, y to the 5. So this is all power 3 by 2. Okay, so let's say break this into, so 5 to the power of 5 square into x. I apply the product rule here. X raised to 4 plus 6 is 10. So then the denominator side, 3 plus 5 is 8. 8 to the 8. 4 squares 3 by 2. So what is mean by, look at this exponent here. Look at this exponent here. See, 3 by 2. What is 3 by 2? 3 by 2 means we can simply write like 5 to the 5 square, then 10 raised to power, then 5 raised to 8, or to the power 1 by 2. Again we can raise the power of 3. Both are equal, so when we open the bracket, just multiply this 2 times, you will get 3 by 2. Okay, so when going forward down, what we're going to do, first we will pull out the perfect square out. So what this 1 by 2 means, taking the square root. So square root of 5 square. So then what is this x? We can write it as x square, x square, x square, x square, 3 4 x square. What is this? 1 2 3 4 5. It's 10. So why I'm writing like this is to make more easy to understand. So I split this x power 10 into 5 square. So the answer is the base are same. So 2 plus 2 plus 2 plus 2 plus 2. It's a 10. So how we can write it like this. So then y we can also split like this: 8 y square, y square, y square, y square. So all are perfect squares. See, so we can pull this out. Make sure there is don't forget to put there's a cube here. this is the main thing everybody will forget. So when we take a square root of this one, we can put it 5, then x. How many x we are going to pull out? 1 2 3 4 5, 5x. So x x x x. So now then the denominator side, y all to the power of q. Why I'm going for the detailed version is to make you understand how we will get the solution. So now what you're going to do is, so 5 okay, so x into x into x is 1 2 3 4 5. So x raised to 5 divided by y raised to 4. So 4 times all power 3. So what to do is just distribute this one. So 5 cube. So x 5 raised to another power. So just multiply. So x raised to 5 into 3, 15 divided by 4, 4 to 3, 12. 12. So you can write as it is, but this there is a value for this. 5 raised to 3, 5 power 3 is 125. So our final answer is going on is equal to 125 x to the power 15 divided by y to the power 12. That's it. There is no more simplification possible from this stage. So this is our final answer. So we can directly see, you can directly jump this into the here. You can directly jump from here to this here, because if we know the rules, if you know the exponent rules inside your mind, we can directly, no need for this all step, you can directly make these things in your mind and jump to this answer very fast, very quickly. Why I am showing this thing is we need to understand how the step by step is going on, how the step by step solution you will get it.